Betelgeuse, the mesmerizing red supergiant that adorns Orion's shoulder, is undergoing a remarkable metamorphosis. This celestial giant, known for its brilliant red hue, has been a cornerstone of the winter sky for millennia, drawing the awe and wonder of stargazers from ancient civilizations to modern astronomers. What makes this transformation so extraordinary is not just the change occurring within the star itself, but the sheer scale and rapidity with which they are happening. This massive star, hundreds of times larger than our Sun, is showing us just how dynamic and unpredictable the universe can be. Betelgeuse's luminosity, the radiant glow that defines its celestial presence, has surged beyond its customary brilliance by an astounding 50%. Imagine a light bulb suddenly burning twice as bright, casting its glow further and with greater intensity. That's what's happening with Betelgeuse on a cosmic scale. At the dawn of this year, Betelgeuse proudly held the illustrious title of the 10th brightest star gracing our nocturnal canvas. Its steady, familiar light was a constant in the night sky, a beacon of stability. However, this unexpected celestial glow-up has propelled it to a prestigious new position, now shining brightly as the 7th star in our awe-inspiring night sky. This leap in brightness has sparked excitement and curiosity within the astronomical community, prompting new observations and studies to understand the mechanisms driving this dramatic change. Betelgeuse, a massive star in its late stages of life, is of immense size. Its dimensions are so vast that if it were positioned at the center of our solar system, it would extend as far as Jupiter's orbit. Eventually, this star will undergo a collapse resulting in a powerful supernova explosion, which may lead to the formation of either a neutron star or a black hole. The anticipation surrounding Betelgeuse's supernova stems from the fact that it will be an extraordinary event. Positioned roughly 650 light-years away, humanity finds itself in an optimal location to witness this cosmic spectacle firsthand. When the stellar explosion occurs, it will produce a breathtaking display of light. Initially, there will be an abrupt influx of neutrinos that will sweep across the Earth, detectable by observatories worldwide. Following this, as high-energy photons escape from the expanding cloud of stellar debris, Betelgeuse will rapidly intensify in brightness over the course of a week, reaching up to 100,000 times its usual luminosity. Depending on the explosion's power, this celestial beacon could rival the brilliance of a full moon and might even be visible during daylight hours, casting distinct shadows at night. This magnificent event will persist for an extended period, offering astronomers an unparalleled opportunity for detailed observations and potentially groundbreaking discoveries. While the supernova of Betelgeuse may trigger speculation and apprehension due to historical associations of such events with ill omens, we can take solace in the fact that we are safely situated at a considerable distance, shielded from any detrimental effects. To fully comprehend the enigma surrounding Betelgeuse, it is crucial to revisit the end of 2019. During this period, the red supergiant star started experiencing significant dimming, a change noticeable even to the naked eye. Observations using the Very Large Telescope in the optical spectrum revealed that Betelgeuse appeared roughly symmetrical, but its photospheric layers exhibited signs of substantial disturbance. Within our line of sight, the photosphere represents the outer layer of the star where light is emitted. Researchers also detected an expansion of the photosphere, giving the impression that the star was swelling when viewed from Earth. This expansion continued at a constant rate of approximately 8 kilometers per second for most of the year until mid-November 2019, at which point the outward velocity began to decline. By mid-November 2019, the flow of material from Betelgeuse ceased, prompting astronomers to capture new optical images of the star. Their observations revealed two surprising irregularities. Firstly, a darkened region appeared in the star's southern hemisphere, creating a striking contrast with a previous image taken at the beginning of the year. Secondly, the surface temperature of the star experienced a dip, dropping by approximately 80 Kelvin between January 27th and February 13th, 2020. The brightness of Betelgeuse reached an unprecedented low approximately a year after the cessation of the outflow. However, the star gradually regained its brightness over the following months, eventually returning to its normal magnitude. This led to the question, what had truly happened with Betelgeuse? all the available evidence strongly suggested that Betelgeuse had undergone an immense and unprecedented event known as a surface mass ejection, SME. This phenomenon bears similarities to coronal mass ejections, CMEs, observed on the Sun. To better comprehend SME, imagine a volcanic eruption on a scale matching that of a star. Material from the star's interior surges upward and outwards, causing shock waves within its atmosphere. Over time, this material forms molecules and dust, partially obstructing our view of the star and causing it to appear dimmer. In the case of Betelgeuse, the SME resulted in the ejection of a mass 400 billion times greater than what is typically observed during similar events on other stars or CMEs. This amounted to multiple times the mass of the Moon, propelled at astonishing speeds. Researchers noted that such an enormous mass ejection from a star's surface had never been witnessed before. The event allowed for the direct observation and examination of surface details using the Hubble telescope, offering a real-time glimpse into the aging and evolution of a dying star. The SME had a profound impact on Betelgeuse, causing it to lose a significant amount of mass in a single event. This occurrence demonstrated that a dying star can experience substantial mass loss beyond its regular annual decrease due to stellar wind. In a way, it was as if Betelgeuse had forcefully expelled its upper layers and was presently in the process of slowly recovering from the aftermath of this event. However, following this dimming event, the star's behavior has undergone a change. Previously, it would pulsate or alter its brightness every 400 days. But now it is pulsating every 200 days. Betelgeuse is classified as a semi-regular variable star, meaning it experiences multiple cycles of fluctuating brightness due to variation in its size and temperature. This red supergiant is known to exhibit two main periods of light pulsation. The first period lasts 400 days and is believed to be caused by pulsations in the fundamental mode. The second period is a longer cycle of approximately 5.6 years, and its origin remains unknown. In their research paper, scientists utilized computer simulations to gain a deeper understanding of the events that transpired. They proposed that an unusually hot gas current, resembling a large and intense bubble, emerged from within the star. These occurrences of hot gas bubbles occasionally arise due to the star's turbulent and convective envelope, which can be likened to a pot of boiling soup where the material is constantly in motion and mixing. As this hot bubble ascended and broke through the star's surface, it triggered the ejection of stellar material. Interestingly, it also disrupted the star's regular pulsation pattern. The star's surface continued to expand while its deeper regions contracted, causing the star to transition from its customary 400-day pulsation to a new 200-day pulsation. Astronomers anticipate that the star's regular motions will gradually stabilize the unusual pulsation over the next 5 to 10 years, ultimately restoring Betelgeuse to its normal 400-day pulsation. Regarding the possibility of a Betelgeuse supernova, astronomers speculate that it could occur at any time within the next 10,000 to 100,000 years. Based on factors such as the star's color, brightness, size, and estimated age, scientists suggest that Betelgeuse is currently in the early stages of helium-to-carbon fusion. This process must continue through oxygen, silicon, and finally iron before the star's core collapses under its own gravitational pull, leading to a cataclysmic explosion. Since Betelgeuse is located 650 light-years away, any supernova event happening at present would only become visible to us after 650 years due to the limitations imposed by the speed of light. Therefore, it is highly unlikely that we will witness the star's dramatic demise during our lifetime. The unique thing about Betelgeuse is that we can actually see its surface, which isn't the case for most other stars. This gives us an incredible opportunity to learn about how big stars like Betelgeuse behave as they get older, including these kinds of surprising mass ejection events. Recently, astronomers made a bone-chilling discovery. For the first time ever, they observed a star eat its own planet 12,000 light-years away in the constellation Ayla. Betelgeuse, with its intriguing name and prominent position in the night sky, has captivated the human imagination for centuries. Its significance extends beyond scientific knowledge, as it has left its mark on pop culture and mythology around the world. Betelgeuse has a rich and diverse origin rooted in the Arabic language. Initially interpreted as the armpit of the giant, some scholars argue that it may represent a hand or shoulder instead. This anatomical association is reflected in various interpretations of Betelgeuse, often linked to anthropomorphic or animal figures across different cultures and mythologies. Betelgeuse carries multifaceted meanings and symbolism. In ancient Japan, it represented a severed limb, while in Brazil, it was perceived as a turtle's leg or a caiman's hind leg. The Sanskrit term for Betelgeuse translates to the moist one, tied to Hindu astrology's Ardra lunar house and associated with the tempestuous storm god Rudra. Throughout history, Betelgeuse has played a significant role in cultural practices and traditions. For instance, in Macedonian tradition, it symbolized domesticated animals and agricultural life in villages. In other regions, such as North Baffin Island and the Melville Peninsula, its rising marked the onset of spring and longer days. Betelgeuse's cultural prominence stems from its affiliation with the constellation Orion, where it is recognized as the star on Orion's right shoulder. As one of the brightest stars in the sky, ranking 11th in luminosity, it captivates and inspires artists, writers, and filmmakers. Betelgeuse, also known scientifically as Betelgeuse, continues to intrigue astronomers and enthusiasts alike with its recent metamorphosis and the potential for a future supernova explosion. Situated prominently in the constellation Orion, Betelgeuse has been a stellar icon for millennia, its reddish glow and variability capturing the imagination of cultures worldwide. In recent astronomical history, Betelgeuse's erratic behavior has been particularly noteworthy. Its variability in brightness has been closely monitored, revealing insights into the late stages of massive star evolution. This variability, initially thought to follow a predictable pattern, has surprised astronomers with its recent changes in pulsation periods and unprecedented dimming events. One of the most significant observations in recent years was Betelgeuse's dimming event that began in late 2019 and continued into early 2020. This dimming caught astronomers by surprise as the star lost a substantial amount of its usual luminosity. The dimming was not only visible to the naked eye but also detectable through precise measurements using advanced telescopes. Such events are rare for a star of Betelgeuse's magnitude and have prompted intensive studies to understand their underlying causes. Researchers have proposed several theories to explain Betelgeuse's dimming episodes. One leading hypothesis suggests that the dimming could be linked to the ejection of material from the star's surface, possibly caused by convective processes deep within its interior. These processes, akin to giant bubbles of hot gas rising through the star's layers, can disrupt its normal pulsation and lead to the expulsion of stellar material into space. Such events, known as surface mass ejections, SMEs, are not uncommon in stars, but the scale and impact observed in Betelgeuse make it a unique case for study. The aftermath of Betelgeuse's dimming events has also been a subject of intense scrutiny. Astronomers have observed changes in the star's pulsation pattern, with the usual 400-day cycle appearing disrupted and replaced by a shorter 200-day cycle. This alteration suggests significant upheaval within Betelgeuse's structure, possibly indicating ongoing instabilities that could lead to future dramatic events, such as a supernova. Supernova explosions are among the most energetic events in the universe, marking the end of massive stars' lives with a spectacular display of light and energy. While Betelgeuse's recent behavior has sparked speculation about an imminent supernova, astronomers caution that predicting such events with certainty remains challenging. The timing of a supernova largely depends on internal processes within the star, including the fusion of heavier elements in its core and subsequent collapse under its own gravity. Betelgeuse, estimated to be around 8 to 8.5 million years old, is currently in the later stages of its evolution. It has exhausted its hydrogen fuel and transitioned to fusing helium in its core, a process that will continue through heavier elements until iron is produced. The formation of iron in Betelgeuse's core will signal the end of stable nuclear fusion, leading to a catastrophic collapse and potential supernova explosion. If Betelgeuse were to undergo a supernova event, its proximity to Earth, approximately 650 light-years away, would make it a spectacular astronomical event visible across the galaxy. A supernova from Betelgeuse would briefly outshine its entire host galaxy, casting shadows on Earth and producing detectable signals of neutrinos and high-energy photons across the universe. The study of Betelgeuse's future and its potential supernova is not only a scientific endeavor but also a cultural and historical interest. Throughout human history, supernovae have been observed and recorded, often leaving lasting impacts on civilizations through their appearances in myths, legends, and historical records. For example, the famous supernova of 1054, which resulted in the Crab Nebula, was observed and recorded by Chinese astronomers and has since been studied extensively by modern astronomers. In contemporary times, advancements in observational astronomy allow scientists to monitor Betelgeuse with unprecedented detail and accuracy. Telescopes like the Hubble Space Telescope and ground-based observatories provide continuous observations of Betelgeuse's variability, helping astronomers refine their models and predictions for its future evolution. Beyond its scientific significance, Betelgeuse holds a cultural and symbolic importance across various civilizations. Its name, derived from Arabic roots, has been interpreted in different ways across history. In Arabic astronomy, Betelgeuse was often associated with parts of the human body, reflecting ancient perspectives on celestial objects. Across cultures, Betelgeuse's prominence in the night sky has inspired stories, artwork, and philosophical reflections on the nature of stars and their place in the cosmos. Looking ahead, astronomers will continue to monitor Betelgeuse closely, anticipating further changes in its brightness, pulsation, and structure. The star's evolution offers a rare opportunity to witness firsthand the dynamics of massive stars nearing the end of their lives. Each observation and discovery adds to our understanding of stellar evolution, supernova physics, and the broader implications for the fate of stars and galaxies in the universe. As technological capabilities improve and new generations of telescopes come online, astronomers will gain even deeper insights into Betelgeuse's behavior and its eventual fate. Whether it undergoes a supernova in the near future or continues to surprise us with its variability, Betelgeuse remains a captivating object of study and a testament to the dynamic and ever-changing nature of the cosmos.